Hey, nice to have you here. Thank you for coming. So in case this is the first time you're seeing the SIP Communicator name, then I'll start with a short presentation. It is a communications application that allows you to do lots of interesting stuff on the internet, starting with instant messaging. We support most of the instant messaging networks out there, like MSN and Yahoo Messenger. But above all, we concentrate on the open and standardized ones, like XMPP and SIP. So a very important centric feature of the SIP Communicator is its ability to do audio-video calls that are, by the way, completely secure and encrypted using different mechanisms, starting from SRDP, for example, an internet specification. And I believe we actually have the author of the specification in the room. So thanks for working on that. And we are also using ZRDP for negotiating the encryption keys. ZRDP is an encryption key negotiation system defined by Phil Zimmerman, specified by Phil Zimmerman, who is also the author of PGP. So I've also thrown in here a couple of screenshots displaying our file transfer feature. We have an image preview here showing. And another feature that I'm particularly glad to talk about today is our desktop streaming implementation that we've just finished this week. You can check it out over there in our stand in the AW building. An important part of SIP Communicator an important aspect is the fact that it is completely very multi-platform. You can use it on Linux, Windows. We have pre-built packages for Mac OS X, Ubuntu, RPM-based systems. So we are using it on all these operating systems. And we are using it daily for our work on SIP Communicator itself. And after we keep using it, and we keep adding features that we need to see in there. And one feature that we particularly wanted is to have conference calls. And that is not necessarily a difficult thing, because most of the providers out there give you the opportunity to give you the option of calling a certain number that acts like a rendezvous service that allows you to meet with other people, and then whatever you say, everyone is hearing. But we wanted more than that. We wanted to see who else is on the call. We wanted to have audio levels. And we basically wanted it to act and feel a little bit like Skype conference calls, not only because they look good, but because they're also useful. It is nice to be able to know who's currently speaking, how loudly, who else is participating on the call. And one big advantage about using open standards in your work is that whenever you think about a new feature that you would like to add to your application, well, chances are that someone else has already thought of it and has specified it and has described a way that it should work. And that's a good thing, not only because you know that the specification that you're going to be implementing is going to be working in different kinds of internet topologies and in different scenarios, but also because if anyone else has implemented that already, or if anyone else is going to implement it in the near future, well, then your solution is going to work with theirs with just like that. Well, and in theory at least, because in practice you probably have to resolve a few bugs before it does, but it's still a great advantage, right? And in the SIP universe, which is the IDF, standards and specifications are called RFCs, and the RFC that deals with basic SIP conferencing is 4353. And for those of you who don't really know SIP, don't worry, this is going to be, it's actually in principle a very simple protocol. So right here we have a basic call, one-on-one call between Alice and Bob. It's always between Alice and Bob. It's just like no one else is calling on this earth. So a call starts with sending an invitation. Alice would send an invite message. Then Bob would reply by sending status responses indicating that his phone is ringing, and then an OK response to actually accept the call. And after Alice acknowledges the call, they would start exchanging media, whether that is audio, video, or both. That doesn't really matter. So if at one point Bob would like to add someone else to the conference, well, he would need to do two things according to that specification. First of all, he would have to reinitialize his existing call with Alice, so that she would know that this is no longer a one-to-one call. And this is important because maybe she would like to know that whatever she's saying is potentially being heard by someone else. And the second thing that Bob would do is start a simple call, just as the one like he's having with Alice, with Carol. Where, again, he's going to indicate that this is going to be a conference call, another one-to-one communication. And after that, they're all going to communicate. Now, what is important here is that both Alice and Carol would be communicating with Bob only. It is up to Bob to mix packets that he's getting from Carol with his own audio and then send it to Alice. And it is, again, up to him to mix packets that come from Alice with his own audio and send it to Carol. This is why agents like Bob are often referred to as mixers. That's how I'm going to call them. So we started by implementing this RFC in SIP Communicator, and this gives us basic mixing functionality, but we wanted to go farther than that because we didn't have we didn't have the possibility to see who else is in the room. We didn't have the advanced user interface and interactivity that we were looking for. So we moved on to implementing another RFC, 4575, which allows us to do just that. So again, it's a simple principle. Once a conference has been established between a number of participants, they could all subscribe with the mixer, with the centric entity, so that they would get notifications whenever something changes in that conference. And whenever the mixer is ready, he would be able to send SIP messages containing XML bodies, indicating if who is on the call, whether they've just joined or left, or whether they've changed their status or name or some other information. And at one point, everyone in the call is going to have a complete view of the conference and be able to show it to their users. Now, that was our second implementation step, and that gave us the notion of rooms. People were able to see the list of participants in the conference call. But we still didn't have that last part about audio activity and about the audio levels in a call. And that was a tricky part because, as you can see here, all the agents in the call are only communicating with the mixer. And the only party here that is able to recognize who's actually talking at any given point is the mixer. He's the only one that can analyze the individual audio streams of all the participants. So we were thinking that we decided that maybe we would need to allow the mixer, give the mixer the opportunity to actually encode that data into the streams and convey it to the other participants. So the protocol that is used in the better part of all VoIP applications, RDP, is also an IDF protocol. Here's how a packet looks. Here's how an RDP packet looks. And obviously the most important part of that packet is the part that conveys the audio, that contains the audio. But in addition to that, we have a bunch of other fields that contain useful information, like, for example, the sequence number, which would allow a user to determine whether or not their packets are arriving in disorder, or the timestamp field, which would allow you to synchronize your audio flows with your video flows, or do other useful stuff with it. And in our case, the fields that were most interesting were these two. The first one is called SSRC, and it's an identifier. Every entity that sends RDP packets generates a supposedly unique identifier to kind of sign their packets. And so if I'm getting packets from Alice, for example, I would see that all of them are signed with her identity, with her ID. So if I'm a mixer, I could include all these in the list of CSRC identifiers, that's what it's meant for, so that the participants in the conference call that I'm mixing, that I'm responsible for, would know the audio that I'm getting in this packet was generated by the entities with these identifiers. And this is what would allow us to show audio activity, to show who's speaking in a particular call. So we're almost there. We almost have the Skype-like conferencing user interface, except for the last bit, showing the audio levels. And why is that important to us? Because sometimes showing audio activity isn't enough. Sometimes you have someone speaking and someone has the microphone, and then at the same time someone else is generating some kind of weird pestering noise, like the Darth Vader people that tend to put their microphones right underneath their nose and they start. So you try to listen to the conference call and understand whatever is being said, but that doesn't happen because someone's So when having audio levels, you could very easily resolve that, because the thing is that normally people that generate that kind of noise don't know that they're doing it. So once you determine who that is, well, you could send them an instant message and say, well, Bob, could you please maybe stop doing that and use your mute button, because we're trying to have a conference call here and you're not really helping. In order to, well, it's actually quite obvious that at this point it's the most sensible thing to do would be to simply add a list of audio levels right after the list of the identifiers. And that's what we did. We added an enumeration of audio levels here that come in the same order as the CSRC identifiers. And that was the last piece necessary to implement the user interface that I'm talking about. We've described and published this solution in an internet draft. You have the name over here, and it's hopefully going to be integrated as an official working group document in one of the IDF working groups, hopefully soon. And this was it. This is what gave us the possibility to have that interface. A very important thing that I would like to say, I would like to express our gratitude to the NONet Foundation from Netherlands, who have been funding this work from the start. So thank you, guys. I don't know if anyone is here, but thanks anyway. Oh, and another important thing is that, again, the fact that all communication is here is encrypted, transported through SRDP, through the ZRDP key negotiation mechanism. Oh yeah, this currently only works with SIP for the time being, but again, as I said, we are going to have an implementation for XMPP Jingo. This is the jobber way of doing telephony for one-to-one calls, maybe at the end of the month or in the beginning of next month. And we are going to port to integrate the possibility of doing conference calls and with all the interactivity, with all the advanced audio level display stuff by maybe the end of April. So that was it. Thank you for coming, and thank you for listening. We have a couple of more minutes, so if anyone has any questions, I'd be glad to answer. Yes? There is, yeah, I didn't say that, indeed. There is a field defined by the 4575 RFC that allows you to map a SIP URI to an SSRC number. Anyone else? Yes? No, you're not supposed to use ZRDP to actually encrypt SIP signaling. You do that normally using TLS, and SIP Communicator supports that. So you can have a completely secure co-establishment and co-scenario with SIP Communicator. Someone stealing your channel? As in a man-in-the-middle attack? Or? Well, that's what ZRDP is built for. It has a special way of verifying identity by involving a vocal check. So you're displayed 4 characters that you have to read to the opposite party, that have to compare them with what they're saying and verify that this is indeed you. So hijacking a connection would only happen if someone is able to imitate your voice or something, which is kind of difficult. No, we don't do any of that right now. Maybe, yeah. One last, I think.
How many participants may I have in one usual laptop?
Well, we haven't really tried to find the maximum number of participants, because that would depend very much on the computer configuration. But this is not meant to be something that you would use in large conference calls. This is a utility that you could use for conference calls with 4 or 5 more participants. And if you would need to have something more advanced than that, then you would have to use a server hosted solution somewhere. And by the way, servers such as Camões could be could also implement the audio level solution and the 4575 RFC. So we would have exactly the same user interface with SIP Communicator as with conference calls hosted by SIP Communicator itself. I was hoping it would do that. Thank you again.